All right, welcome to another quick session of RTX Compare. This is going to be another quick one, Qwen 332B. This is quantized down to 3 bits, and we're using an 8K context. And the reason why we're testing this today is to demonstrate what happens when you have a model bleed into CPU memory. So this is 16 and a half, 17 gigs model weight, and it's actually sitting on a 5070 NVIDIA GeForce RTX 5070 Ti, which has 16 gigabytes of RAM. So the weights alone are already bigger than the card itself. So it's definitely going to bleed into motherboard memory, which is significantly slower than the DDR7 that's on the card. So while it's DDR5, the memory bandwidth is just different when you're talking about GPU memory and CPU memory. Anyways, enough talk. I'll show you what happens. So typical query, tell me about Tyrannosaurus Rex. And for a baseline, we tested this earlier with the 4090, an RTX 4090 with 24 gigs of RAM on that same device. And the 4090 performed admirably. We were clocking it at around 60 to 70 tokens per second. And it's a pretty fast speed for a 32 billion parameter model sitting inside a 24 gigabyte of RAM, of VRAM card. So I like working on PCs that have graphics cards because they're extremely fast compared to the DGX and the Mac systems that we test normally. But the problem is it's difficult to find a model that's significant enough to be able to fit in these 16, 24, 32 gigabytes of RAM, right? 32 is only one card, the 5090. The 4090 has 24, although a lot of places in China will will double that RAM by adding their own. But most cards in the market right now are 8 and 16. And 8 is really not a reasonable size. 16 is the base minimum. So we're still waiting for it to actually finish the prefill, but it looks like it's starting to work now. And as you can see, it is showing us our thinking process, and that is looking very much like 10 tokens per second. Now it's actually trying to look at RAG, which doesn't actually exist for this model, but essentially 10 tokens per second and that extremely long prefill time of 17 seconds. I think it's actually longer than that. It's 17 seconds when it started showing that it was thinking, but prior to the actual thought, a significant time. I'll have to look at the memory here, the timestamp here, but I think it was at least 30 seconds. So there we have it, 10 tokens per second. Let's do a quick follow-up because that was cold. But the context size is fair. It's 8K, and it wasn't a big query, but you're looking here. Essentially, the split is 80-20 or 78-22. 78% of the entire LLM is set on the GPU, and the remainder is on the CPU itself. But CPU speed, I'm using 6,400, I think, megabit transfer DDR5s, but you're comparing it to DDR7 on board, a graphics card. So it's just a lot slower. I think the memory bandwidth is, if I'm not mistaken, 50 compared to, I think, on the card itself, I think it's 600. So at least 12x of speed. So yeah, I think this is running at around 10. Let's do another one. Let us actually do our typical 18K file. this model is actually able to do tooling, and let's actually get the notes and actually do our query here. Ingestion was fine, as you can see the file was attached pretty quickly, but let's take a look at what happens when you actually run Python. If you look at the memory usage here, it's not as evident on PCs, on the activity on the GPU. It's not really any nice graphing for it compared to, let's say, the DGX Spark. Beautiful. You can actually see each of the cores and percent use on it. But here it's just showing you what the load's looking like, how much power is being used by the GPU. But you know, it's been some time, and it still hasn't done the actual, I guess, ingestion of the data. It's ingested the file. It hasn't actually grabbed the file contents into memory yet. That's going to enable it to figure out the number of columns, right? Because it's actually trying to execute the model. So what it's trying to do is say, hey, I've opened up the file. I'm sweeping through each row, and I'm noticing the commas. This is a special file that has, it's not typical. It's got some text in it, which makes some cells really large. And to be able to identify the nine, it's 398 rows by 9. It takes some significant bandwidth. And what we're trying to showcase here is you have this desktop is 32 gigs of onboard memory and 16 on the GPU. So you have up to 32 gigs to play with, and it should be fine on the 32 gigs. That's probably has 10 allocated to operating system, 20 available, but it should be calculating this right now. But it's been some time. I think it's 7 minutes now on this video, and we still, let's say it's 5 minutes or 4 minutes. We still haven't gotten any kind of information about the file yet, and this is actually a not good user experience, because one, it's slow, and two, it's not necessarily giving us instantaneous information, or periodic information. It's just sitting there. I don't know if it's hung. I know that it's not, because it's still moving here. But if you're not actually watching this information, you won't know. So there we have it. It's actually starting to think now, and yeah, that is probably eight tokens per second. Let's do our trusty visualizer here, and let's do 8. I'm just eyeballing it, but let's see. In fact, 8's appropriate. Yeah. So it's 8 tokens per second. It's still usable. Humans can only read up to 5, but it's not as blazing fast as it was earlier on the 4090. And this is what happens when you are utilizing the motherboard's memory as opposed to the onboard memory on the card itself. So now we're actually, this is all a model issue, but it's actually errored out. See, it's errored out because it has run out of context from the 8K that we allocated it. See, we put 8K, and it's already kind of exceeded that already. So this is what happens when it overflows. So normally what we do right now is adjust the KB allocation, but how much more can you really fit? It's it's a small relatively small amount of memory to be allocating to a large language model. So, anyways, there we have it. Try not to install Qwen 3 32B on a 16 gigabyte card. If you have a 5090, it should be okay. If you have a 4090, as long as you have short conversations, it should be okay as well, except you won't be able to do anything else other than just the large language model itself. Thanks a lot.